If an individual saves $6,200 and elects to place the total dollar amount into a savings account earning 3.25% APR compounded monthly, how much will the original deposit grow to in 11 years? This is simply a one lump sum deposit into a savings account, and it'll be left alone, just compounding interest. So we're going to use the formula A equals P times the quantity 1 plus APR over N raised to the NY power, where each of these are: A will be the amount at the end, P is the principal or initial deposit, APR is the interest rate as a decimal, N is the number of compounding periods in a year, and Y will be the number of years. So we simply have to identify which one of these numbers in the problem corresponds to each one of the letters in this problem. So, if an individual saves $6,200, that right there is your initial principal, that's your P. So we'll say P is equal to 6,200. They're going to place the total dollar amount into a savings account earning 3.25%. That's the APR, which you'll see that right there. So it really hammers home that it is the APR. And we'll convert that into a decimal, which will be 0.0325. Compounded monthly, well, compounded monthly, that would be the number of compounding periods in a year. So that would be 12. So over here, N is equal to 12. And we're going to do this for 11 years. How much will the original deposit grow to in 11 years? So that is your big Y. So we simply go ahead and put this into the formula. So once you finish writing it out, you'll have A is equal to 6,200 times the quantity 1 plus 0.0325 over 12, and that will be raised to the 12 times 11 power. You can punch all this into your calculator if you have a sufficiently strong enough scientific calculator. You can also do it piecemeal, or you can use a web-based browser calculator such as web2.0calc.com. Let me write that out for you. But if I were to do this piecemeal, I would have the following. A equals 6,200 times the quantity 1 plus 0.002708, and this actually is a repeating decimal, and I've rounded off to the 6th decimal place, which should hopefully take care of some of the round off error, and then this will be raised to the 132nd power. At this point, I've added these two and gotten 1.002708, which I will then put into my calculator and raise to the 132nd power, and we'll end up with this value right here, 1.428999711. And now my formula has been reduced down to A equals 6,200 times 1.428999711, and that will yield a value of 8,859.782082. And of course, to input this answer, you want to round to the nearest whole dollar according to the instructions. So this will be 8,860, and that's what you would input into the field for your answer. Now, if you were to use a calculator and type all of this in at the same time, it would look like the following. We type in 6200, multiply, open parentheses, 1 plus, and then we're going to have to do a fraction here, so I will open another set of parentheses, type in 0.0325, I will divide that, because it is a fraction, by 12. I will close the set of parentheses. And then I'm going to have to close it again to make sure that I've got everything wrapped up. Now I'm going to use the exponent key, x to the y, or I could simply use Shift 6 on the keyboard, and that would give me the little hat key, which represents raising to a higher power. I will open a set of parentheses, and then I will type in 12 times 11, and then close parentheses. And you'll see right here, where I'm about to highlight, that it looks just like how it's written in the problem. And then we'll left click equals, and it will give me 8,860.170, which is a little bit more than what we calculated, but that was because there is a round off error inherent in the problem when we rounded those decimals by doing it piecemeal. Either way, you would end up with $8,860 rounded to the nearest dollar amount.